Hello everyone, thank you for joining us. So this is our What's New in Maple 2018 webinar, and I'm going to be talking about a lot of new features in today's webinar. I won't unfortunately have enough time to talk about everything that you see listed on your screen here today, but I want to make sure we kind of focus in on a couple really big additions that are hopefully going to benefit you and how you work inside of Maple 2018. So what I'll start with saying is that Maple 2018 really features a lot of new stuff that it includes a lot of substantial enhancements that are really going to focus more on how you interact with Maple. So we're going to change a little bit of the way that you work inside of Maple. We're going to make it a little bit easier for you to do things. And we really want to try to stress the point that no matter how you are working inside of Maple, you're going to see some benefits. You're going to see something that will hopefully help with the way you do things. So there's going to be something in there for everyone. So with that in mind, I'm going to jump straight in because we've got a lot of stuff we want to talk about today, a lot of stuff we want to cover. So let's start here with the Intelligent Context Panel. I'm just going to press F11 to move over to slideshow mode for a second. So the first topic we're going to talk about here is this notion that the context panel really brings together and enhances some of Maple's most powerful clickable math tools. So in previous versions of Maple, you would have had something called the right-click context menu, where you would have gone to an expression, right-clicked on that, and you would have seen a menu that would have operations that were relevant to that expression. So what we've done in 2018 is we've taken that entire right-click menu, and we've moved that over to the right side of your screen and put it into what we call the context panel. So alongside of the right-click context menu, you also see things like our smart pop-ups have been merged in. So these are the things you see here as previews at the top. And we've also added in a number of different tools. So we've added in things like numeric formatting, units formatting. We've added in controls for component properties. And we've tried to do all this in order to make the context panel provide you with a very highly discoverable way of exploring all of Maple's functionality. So just to kind of go a step backward here, the main idea of what we're talking about when we use a context panel is really that when you click on a mathematical expression, Maple analyzes that expression and presents you with a list of the most relevant operations and tools. Alright, so let me show you a couple of examples here. So actually I'll open up a new document just to show you this from the start. So something like we had before. So we'll have x squared times sine of y. Something simple as that. So if we've entered this expression, we go over here to the right side of our screen, we can now see there's a number of different options that are being presented to us that are relevant to this expression. So we can, for example here, we can differentiate this with respect to either x or y. I'll differentiate with respect to x. There's a result. And then based on the result here, we can continue on. We can do a 3D plot with respect to x and y. There's our 3D plot. If we now want to change some properties of the 3D plot, we can change that. So we're stringing together a number of different operations here. We're starting off with our expression, we're differentiating it using context panel, we're doing a 3D plot, and we're even changing the 3D plot. So all this is it's easy to use, it's really easy to find as well. It's highly discoverable now being in Maple's right side context panel. So let's look at a couple more examples. I've prepared just kind of some canned examples for us here. So say we have an expression like something like this differential equation that we see here. So with differential equations, this list of options here changes. So we can now go down and do something like solve the differential equation for f of t. And there's our solution there. And let's do a couple more examples here. We'll do one for dynamic systems. So we've now got this dynamic systems object here. We'll scroll down, we'll right down near the bottom of the list, we'll see dynamic systems. And let's do a Bode plot here. Alright. There's the plot of this dynamic system. We'll continue on. This is one of the more popular ones with using the context panel system. So if we have a matrix, you'll be able to do things. We'll be able to go, say, over to eigenvalues and find the characteristic polynomial. We can go back. I'll click back on the matrix here, and we can go down there. We can go standard operations, find the determinant. We can go back to the matrix, say go down to statistics, and we'll do something like, let's scroll down this list here. Let's see if we can find something interesting. Oh, actually, we'll just do something simple as finding the mean. So this gives us the 3-column means here. So this column, this column, this column. So there's a lot we can do within that context menu. And you can see that this is always changing on the fly. So let's do one more example. I'll do another example of importing an audio file. So let's do this using some of the tools we've got in Maple. I'll go to Tools, Assistance, I'll go to Import Data, and then Maple's got a whole bunch of pre-canned examples that if you go into your Maple installation directory under Data, you can find them under here. There's data sets, there's audio, there's some images as well. And I'll just import one here from maplesim.wave. And I'll just call this file audio. Press done. So here is the audio file I've just imported. And then we can go over here, we can say preview the audio, we can do some plots. I think I'll go over to single processing and let's do the signal plot. So now we've generated a plot based on this data that we've imported from an audio file. All right, some more cool stuff that we can do now. So say we've got some expressions with units. So I'm going to add up these two, and I'm going to just press Control equals or Alt Enter on my keyboard in order to get the result shown to me in line. So this is the result of adding up these two expressions here. And now at the bottom of your context panel, we'll be able to do things like choose the output units. So let's choose the unit here. We'll switch from kilojoules over to joules. We can also control the numeric formatting. Here we can go to making this fixed with 2 decimal places. So we're basically able to use all these controls that we had previously available to you through things like the format menu, but they're now front and center sitting over here in the context panel. So this is pretty exciting new functionality because it makes it very, very easy to get at and easy to change the options that you have in front of you. All right, let's look at the smart pop-ups. So I mentioned before that these have been incorporated into the context panel as well. So the context panel, if you look at the top here, we have these smart pop-ups. And these were previously kind of shown to you inside of your Maple document, but now if you have an expression like sine times 2 theta, we can go over here, we can see the result of expanding this, we can see the result of generating a 2D plot for this, or we can see the result of applying various trigonometric identities. So let's just pick this one here from the list, and this applies the full angle reduction identity to this, and this is the result. So the smart pop-ups, they're kind of a preview before you apply an operation. It's kind of the main idea with smart pop-ups. But again, these are also part of the context panel, so they're available to you when you start up Maple and you want to perform an operation. All right, another cool example is building plots. And this is actually something that if you have a copy of Maple 2017, you would have already seen this. So in 2017, we started working on the context panel. And the way that we started working on it was to introduce the plot builder into that right side of the Maple's menu. So what we can do, and the whole idea with the plot builder, is we enter an expression, something like even this set of inequalities, and this, by the way, is something that is new in Maple 2018. I go over here to plot builder, and then this basically changes the plot builder entirely. So now we see that we can choose here from 2D inequality or 2D implicit plot. So the new thing we can do in 2018 is do the inequality plots. So we'll choose inequality plot. And now we're able to customize our inequality plot using the controls you see over here. So here we can choose the color, we can go to 2D options, we can mess around with our transparency if we want to make the color a little bit lighter, we can change our grid size, we can add titles and so on. I'll just hit return there to get that title to go in. So we have kind of all the controls you would have over regular plots are exposed to you within the plot builder in the context panel. So this is a great way to get exposure to the various types of plots that exist within Maple. But it's also a great way to kind of learn how to use these commands. If you want to, you can go to here where it says show command, toggle that, and that gives you the full command that you can reuse later on. So here we've built the command code for generating this exact plot. So it's again, you're learning how to use the plots, but you're also learning the code syntax for it. So it's a great way to get exposure to these tools inside of Maple. This is another one that I'm pretty excited about. So if you're using components at all, I'll open up our palette here for components. If you're using any of our interactive embedded components in the documents you're working with, the context panel now reveals the properties of these components. So here, for example, I've inserted a slider. And now if you go over to the context panel, we can adjust the tooltip. We can set the value at lowest position, highest positions. We can show axis labels, snap to axis ticks. We can control all the properties, including if you click right here, you can control the code for that slider. So if you're authoring applications inside of Maple, this has all of a sudden become very, very simple because you don't have to right click on things anymore. It's all right there within that context panel. And the same thing is true if we open up a table. So if, again, we can go to Insert, Table to insert a table. It's right here at the kind of 2/3 mark of this list. And once you insert a table, you'll be able to control all the properties of this table. So here we can turn off the exterior borders. We can leave the interior borders off as well. So we can just hide the fact that we're using this two-table thing. We're going to kind of use it just for layout, we'll say. We're able to, and I'll just put my cursor in this cell. I think we can go down here, change the cell color. So I'll change this to a purple cell. And I'll change this to a yellow cell. So the controls that you would have previously had for tables are all now found within the context panel as well. So this is the final point I wanted to make, but you might see more examples as we flow through the rest of this presentation today. But the context panel, it's important. And it's one of these technologies that comes along every so often, and it really does affect the way that we all work inside of Maple, because there's really something that everybody can work with here. There's application authoring with these changes for component properties. There's plot building. There's changes for making sure the smart pop-ups are included. There's unit formatting. There's accessibility to basically the entire Maple language under the hood of this whole context panel system. So this is one that I highly recommend you guys check out, and hopefully we can do a little bit more in the way of talks on this in the future, because it's really going to change the way a lot of people work inside of Maple. But with that, I need to move on and talk about some more functionality. And the next one that I want to talk about is units. And this one is another important one. It may impact you a little bit more if you're working kind of in engineering domains or if you're doing some type of research. What we've done for units in Maple 2018 is we have expanded the domain of where units can be applied. So previously, there's a fairly short list of where units could be applied in computations in Maple. But now many functions have included support for units. So what we focused on was things like fsolve, so that's numeric equation solving. We also added unit support in things like the optimizers in the optimization package. The int command can also handle units. So there's a ton of kind of core functionality. We kind of consider this stuff to be really important to how people work inside of Maple that can now just natively support units. So to show you exactly what I mean here, I'm going to open up one of these applications that we have highlighted here. So this is under single stub matching. And this is a new application. We've introduced this one inside of Maple 2018. And I won't go through the application to talk about the application at all, but if we just scroll down here, it's a pretty simple application. The idea really is here just that if we scroll down here, we have some parameters. So it's this Z0, ZL. We have some equations for the wavelength and the circuit. And then what we're just using is fsolve. We're giving it this system, and it returns a result that includes meters. So it's as simple as that, right? That previously we may not have been able to generate a result here because Maple would have just given you an error saying, okay, we don't understand what units mean here. But now units are fully supported within fsolve, within integration, within optimization. So you're able to use those as a complete part of your toolchain. All right, let's continue moving through this, through our workbook. So the next important feature that I want to talk about is coding in Maple. And this is certainly one that I've used quite a bit already. And by the way, I'll just mention this very quickly. If you click this button over here, these kind of double arrows, this collapses or expands the context panel, but you can also hover over it at any point. So I'm just going to close it for now just to give myself a little bit more screen real estate, but it's always just a matter of clicking this button or hovering over it in order to get access to it again. So coding in Maple. This is one where we had some fun this year. So we've added a number of features that we probably should have done a little while ago, but we have now added in, and it just makes it a little bit easier to code within Maple. So I've mentioned this a number of times already, but my favorite change to Maple 2018 is really just that you're able to cursor into the code edit region. Previously, you would have had to put your hand on your mouse and have to click in here, but now you can move from this point in your text, you can press down, and you're just moving into the code edit region. Something else you'll notice within code edit regions is that if you start typing in a command, you'll see automatic command completion. So linear algebra, I can press tab, and we'll do determinant, press tab. So we're getting full command completion. This is shown to you automatically within the code edit region. And by the way, I probably will just mention very quickly, if you're not sure how to insert a code edit region, or what I'm even talking about with code edit regions, the code edit regions are something that you can just go up to this button right up here. You just click on that, and this will insert a new code edit region into your document. And really what these are for is incorporating blocks of code inside your document. So this is kind of a way that if you're using a nice document, you've got lots of nice typeset math around it, but you want to have a block of code that's run that you want to show off, then you can use these code edit regions to show off that block of code, or to kind of take advantage of some of these cool new technologies that we have for being able to edit code within these regions. All right, so some more changes, and I'll mention this. So we've done a lot of work to unify things like our code edit region, as well as some of our other coding tools. And one of the other coding tools we have available for you is called our code editor. And you'll see this for the embedded components, but you also see it for our startup code. So one way to get into it is just to click these gears up here, and you'll frequently see this when we're working with math applications. And this opens up this little window, and this is literally our code editing window. So within this code editor, I'll just type in our procedure here. Let me just make this a little bit bigger. So make f a procedure of x, and I'm going to make some errors here just so you guys can see this. And then we'll do end proc, and there's our procedure. So what's new in Maple 2018 is that we now have support for Maple Mint inside of our code editor. So Maple Mint, for those who don't know anything about it, it's kind of our static code analysis tool. So you run Maple Mint on procedures, on modules, and you get information back on how to go through, clean your code, if there's any parameter conflicts, unreachable code, unused parameters, things like that. So in this case, if we look at this small code snippet that we have here, we can see info line 1. These names were declared as both a local variable and as a parameter x. So that's obviously an error because I have a parameter here for our procedure called x, and I have a local called x. So I'll go through, I'll delete that. That cleans up our first one. These parameters were never used, x. Okay, we'll get to that in a second. These local variables were never used, y. So let's start adding some information here. So let's do y, and we'll do an assignment. And we'll use the same technology as before, so linear algebra, I'll press tab. And then we'll go to determinant, and we'll find the determinant of our incoming variable, or value x. And then we'll return y. Go to the bottom. And now we've cleaned up all of our code. So this is, it's basically giving you a little bit of a coding environment that you can use to test out various code. If you wanted to, if I want to just put some more simple code here at the bottom, I'll press 1+1. If you switch over from parsing errors over to console and hit this exclamation point, this will actually run through this code and give you a sample of what the result would be. So here we're actually using this as a console, and we're getting a console output that I'll just hide the output from f. And we'll rerun this again. And now we just see that 1+1 is, as we see at the bottom, 2. So there's full coding here. There's the console to get output. There's also on the side here, we can see that we have cursor position here. If you do have any errors, then I think we'll get notification here that there are errors at certain points in our worksheet with little arrows or lines over on the right side of our screen. So all these changes have kind of come into Maple in order to make it a little bit easier to work with Maple as a coding environment. All right, so I won't go too much further into coding at this point. I will very quickly mention that there have been changes to standardize Mint and Maple Mint. So Mint is kind of it's an external tool that's used on text files. And Maple Mint is kind of the internal tool that's used inside of Maple to be run on Maple code. So both analyze static Maple code and give you results. And what we've done for Maple 2018 is we've really standardized the code base for both of these two. So the errors you're going to see between these two are always going to be uniform. You'll be able to see the same things. If you want to read more about this, I would recommend going into the help pages for either Mint or Maple Mint. Or if we jump back to our help system here, there's a whole section on this within the language and programming what's new page. So I'd recommend just going through here, reading a little bit more about this. And there's even more text on some of the commands we've updated for Maple 2018 as well. So there's always a lot here. Again, we can only talk about so much in this short time. All right, next example. Let's get into some data analysis. So I'm again going to jump into our slideshow mode, pressing F11 on our keyboard. So interpolation. We've had a common request for quite a while now, and that's to add a generic interpolate command that will work on unstructured data. So what we've added in 2018 is in fact a full package. We call the package Interpolation. And this is for interpolating structured and unstructured data in any dimension. And the supported methods we see here, it includes things like there's kriging, there's inverse distance weighted, natural neighbor, and there's a whole bunch more. So I want to show you a really nice example here that was put together, and it's available through our Maple Application Center. And it's this smoothly shaded temperature map. And you can again, if you go into our Maple Application Center online, I'll just pull that up very quickly and show it to you. So here we have our Maple Application Center. And you can just look for this one, smoothly shaded temperature map, in order to be able to reproduce this. And this application, this is doing something we couldn't do before. We're actually smoothly shading temperatures through this geographic map. So here we've got a map of the states where we're showing various states. And this is temperatures, and this is in degrees Celsius here. So kind of cooler temperatures here, warmer temperatures here. We're using the interpolation techniques to basically fill in values in between these sections. So we've got some readings from, say, a temperature tower here. We've got somebody taking temperature values here, and then we don't have them. We have the next one over here. We have it over here. So we're interpolating between certain areas. So this is new functionality. It's a lot of fun. I would recommend spending some time with this and having a look at this application as well as many more that we have stored within our Maple Application Center. All right, in the interest of time, I'm going to move on. Thermochemical data. So in Maple 2017, we introduced thermophysical data as a package. And in 2018, we introduced the chemicals subpackage for thermophysical data. And this gives properties for an additional 2,000 chemical species. So before I show an example of that, I'll also mention that something else we've done is we've updated the CoolProp Fluid Properties engine to version 6.1, which means for the existing users of the thermophysical data package, we've actually added in the newest definitions. We've worked to make sure that's up to date as well. And it's not listed here, but I'll also mention that we've also done the same thing for our scientific constants package. So the scientific constants package has been around for a long time. That one has been updated with the latest values, and you'll be able to find the details on that again within our pages on the what's new. So to walk through an example here for thermochemical data, here we have our example for adiabatic flame temperature butane. I think I said that correctly. If I didn't, then that's all right. And we set up our system here, and if we just scroll down, I'll give you an idea what all this looks like. Here we're using the thermophysical data package. We're using the chemical subpackage, and this has a command called property. And we're going to look for the heat of formation. We're going to give it the chemical breakdown here. We're going to use units. Again, this is a package that units are front and center. You're going to see units all throughout the thermophysical data package. So whatever you're doing within thermophysical data, they're going to have associated units. And down below, we'll compute the enthalpies of the combustion products at temperature T, the enthalpy of the reactants, the total enthalpy of the combustion products, and as we saw before, you're going to use fsolve to get a result. So here we have fsolve, and this returns a result to us in Kelvin. And what we can do as well is if we wanted to go down here to the bottom, I'm just going to rerun this whole worksheet here. All right, and then let's step back up, put our cursor up here, and then let's change this from Kelvin to Fahrenheit, and there's the result there. So again, I just hovered over the context panel in this case just to switch the units out for us. So units are front and center in the side of this package. Units are all over the place here. Again, if you're interested in this stuff, I highly recommend going through and having a look at this. As you can see on the side of our screen here, there are lots of more new examples that have been introduced specifically for thermophysical data, and all this works. So there's a lot of new material that I would definitely recommend spending some time with. But let's get into the real interesting stuff. Let's get into talking a little bit more about advanced mathematics within Maple. And this is a slide that we could certainly spend hours talking about, and I'm going to do it a great disservice by only spending a couple minutes here. But every year we add a lot of new functionality. We are constantly working to update the routines we have inside of advanced mathematics. So you'll find changes to, in this release, you'll find changes to things like integration, differentiation. There's dsolve, there's pdsolve, there's simplify. There's all across the board where we're working on various changes. Now, in a lot of those, I won't even show to you today. But again, if you go into our help system, you'll find a help page here called Advanced Mathematics. You'll be able to find all the changes we've put together. Here are examples of how we've improved this in this release. But let me focus in on a couple of the newer features that we have. One is a new computational geometry package. So this computational geometry package includes commands for things like convex hull, DeLonghi triangulation, I know I mispronounced that one, polygon triangulation, and the Voronoi diagram. And here's an example here of just generating a Voronoi diagram on this random matrix, the resultant here. If we scroll down, this is one that's very useful. I've used this one a couple times already, is date and time tools. So we can now declare dates and times, and these are brand new objects inside of Maple 2018. So the syntax here is pretty straightforward. Date, it's year, month, day, and this creates a new date object. If we create another date, we can minus the 2 here by doing d1 minus d2, and it gives us a value in milliseconds. Units, I believe you're probably seeing a common theme here. If we want to go from milliseconds here, I'll keep this one open now, we can change this to hours. So we're able to change very quickly with time and dates as well, because they also have associated units. Inside of the date and time tools, we also have a new calendar package. So we can do things like play with time zones. We can find the time here with the system clock, and the system clock is coming out of the local time zone here. We can determine if this is a leap year. And you can see here there's a whole slew of new commands that can be used within calendars. And one other addition that is relevant for people using dates and times is actually that the finance package has been updated to use dates and times by default. So if you have a date and time, you put that into a finance command, you're going to be able to use that by default. All right, some more changes, and these are just kind of more aesthetic ones. So if you look inside of graph theory, here are a couple of new special graphs that we've added, and these are the plots using the draw graph command, pardon me. So these are all nice new plots. These are new plots of the special graphs. And there's a whole bunch of new commands that have been added to graph theory as well. So we won't have time to talk about those, but this is probably a good time to very quickly mention that if you do go over into our What's New, if you go down here, Index of New Commands and Packages, this is always the way I learn kind of what's new in a release of Maple. I scroll down this list and I have a look at kind of what's new and what's happening. So if I scroll down this list, within graph theory, I'll be able to see there's support for the special graphs here. Then there's a whole bunch of new commands that you can explore as well. So there's new stories, there's a whole bunch of new functionality. Definitely go and check this stuff out. So PDEs, here's another area that we spent a lot of time working this year. And in this case for Maple 2018, we've added support for PDEs with boundary conditions, specifically for problems in 3 independent variables, which can now be solved, and more problems in 2 independent variables which are now solved. So I will just very quickly roll through this page. I won't walk through this example at all. But as you can see here are some new examples of functionality that we're able to work with in Maple 2018. If you are interested in any of this, this is again one of those areas that I would recommend going through our What's New pages, our help system. But there's also a project page which we maintain online. And this is the Maple Physics, DEs, and Mathematical Functions project. And we actually are working on this throughout the year. So if at any point you're interested in kind of what's new and what's happening, we're pushing updates on basically almost like a daily basis to make sure that we are trying to push the boundaries, trying to keep this stuff as cutting edge and as forward as possible. So anyway, this is kind of a very, very quick sampling of some of the things that has been added for Maple 2018 for PDEs. All right. I did want to show this command, practice sheets. Let me just make some more screen real estate here. So the student package, for those of you who don't know anything about it, the student package is a collection of subpackages that are basically aimed at certain courses. So there's a student calculus 1 package, there's a student statistics package, there's a student package for linear algebra, there's some multivariate calculus, there's vector calculus. There's also a package called student basics, and this is really kind of meant for more almost like high school level mathematics or even like grade school level mathematics, that we're trying to add some functionality that's going to be relevant. And one of the new commands we've added is called practice sheet. So if you do with student basics and then we run the commands practice sheet, And the idea with Practice Sheet is that you give it kind of a formula. So here we're asking it to generate problems that are of the form integer plus integer. So what that generates is this. It gives you a new table, and as a student I can go through here and I can fill this out, and we'll step through here. I'll get this one wrong, get this one right, I get this one wrong, we'll leave the rest of them as they were, check my work, and then we can see here basically as we step through this which ones we've got right, which ones we've got wrong, which ones we've left alone. We can also press New Sheet. That gives us a whole new sample of problems. So it's kind of a quiz generator. So there's no grading really plugged into this. You're not going to hook this into a grading system, but it's really meant just to kind of be fun little exercises that you can give to a student, especially those who are just learning, arithmetic or multiplication tables as they go. But there are also kind of more advanced tools that are available. So here we have a practice sheet that we've generated that lets you step through integration using the power rule. So we're giving them basically, here are a number of different options. We're giving them a title. Here's a message. So it's kind of building out a full interface for being able to step through and learn a little bit more about integration. So it's not just that basic level of mathematics that we're targeting this functionality at. So there's these extra tools which will let you generate problems that are a little bit more advanced in nature. So that's within the Student Basics package. There's more content there that will be relevant to you, but I would recommend you trying these ones out, seeing if they fit within what you're doing. And if nothing else, it's the type of thing you can just give to one of your kids and have them mess around with. So, okay, so speaking of sharing content or having other people use the content you've made inside of Maple, and one of these things we've had asked for a number of years is the ability to lock down content. And the reason why we have been asked for this is, say you've generated some document, you've generated a math app, and you spent a lot of time making sure that this math app is working just the way you expect it to. Now, say you give this away to somebody else, and say that person goes in here and they try to delete this slider. Well, we don't want that to be able to happen, right? So what we've added in is this editable flag you see down here. So if this is editable, I can now go in and I can delete this. But by default, a lot of our content, especially our math apps, are now marked as non-editable, which means I can't delete this. So this becomes static content. You can experiment with it, you can use it all you like, but you're not going to be able to edit it in any way. So this kind of provides this kind of lockdown. It's kind of a very simplified lockdown. It's not going to save them this content if they do unlock it, but it's kind of just a very, very quick and easy way to make sure the content stays the way that you had hoped it would stay. So the content is available for the full worksheet. It's also available if I kind of go back to this table here. This is actually an inserted table within Maple. And I'll switch over to the table tab here, and you can see here that we can flag just the table to be editable or non-editable. So we can kind of mark certain parts of the Maple document as being something that has editing abilities and other parts which do not. So it's kind of it's one of these features that we're hoping will help and improve with the authoring experience. It'll help to improve when the students are using this stuff too, because no longer can they accidentally just delete a plot or something else that's important as a part of the worksheet. So again, this is something you can flag for tables using this editable flag. You can go down to the bottom of your screen, you can flag it for the whole worksheet just using the same flag here. All right, and where I'm going to leave us off today is another interesting new feature talking about protecting your content. Encrypting procedures. So say you've got some code that you've written in Maple that you want to share with someone, but you don't want them to be able to see the source. And this is kind of one of those things we've had for a long time, because Maple does expose a lot of its source code to the user base, right? You can do things like show stat, or you can print procedures. You can see a great percentage of Maple's source commands. They're just completely open out there. But say you want to encrypt some procedures. You want to share something that is proprietary. And this specifically comes out of kind of a lot of our users who are professional users who are sharing work with customers. What you can do now is you can add this option called option encrypted. So if this is your code here, I've got a simple routine here, and this is just going through, it's implementing a block game that's described as this Rosetta code problem for the ABC problem. So we take our code, we then take this code, we save it out to a MLA file. We call this abc.mla. So we're using the save live command or something like that. And once this is read back in, you can eval can spell, but when you do so, you can't see any of the code that's inside of it. So this is a little bit different than what we would have been able to do before. Previously, we might have been able to see all the source code for this procedure. But now that we're using the option encrypted, we're able to hide away all this code, and you're no longer exposed to it. So it's kind of a good way to kind of keep your source. You're keeping it away from other prying eyes and so on. So it's another one that came in as a frequently asked for, frequently requested feature.